Hello, my name is Charles and Anthony, and today I'm going to present about Project 2, Tool and Die. Introduction. What is tool and die? Tool and die manufacturing is essential in fabricating and producing durable parts and components. This process consists of cutting, forming, stamping, and forging metal to create materials that vary in shape, size, and function. Tool and die manufacturing also involves the production of metal molds to shape plastic, ceramic, and other material for traditional and injection molding. Fundamental of die cutting operation. Plane blanking. The plane blanking operation consists of a punch going through the material during the working stroke, and on the return stroke the material is lifted with the punch and is removed by strip plate. Piercing. The operation consists of simple hole punching. Punching is the scrap and the strip is the workpiece. Lancing is a cutting operation in which a hole is partially cut and then one side is bent down to form a sort of tab. Cutting off and parting. Cut off is a term that is commonly used in metalworking industry to refer the process of separating a part from a larger sheet of metal. Parting off, on the other hand, refers to the process of cutting a groove or slot in a piece of sheet metal to create a specific shape or feature. Notching. Notching is a metal cutting process used to sheet metal or thin bar stock, sometimes on angle section or tube. Shaving. Shaving is a operation that may be used after blanking to give a smooth square edge and greater accuracy that can be achieved in ordinary blanking. Trimming. A pinch trimming die is frequently used for trimming cup-shaped parts with only the vertical action of the press. Next. The cutting action in punch and die operation. Punch and die basic. A punch is a solid metal piece positioned vertically above the die. The die corresponds in size and shape to the punch and is secured directly beneath it. Then the punch is usually hydraulically driven to meet the die. The location and alignment of the die are critical, with the material to be punched in between. Three phases of punch and die operation. First phase is deformation. The punch forces an initial deformation of the material to be cut. Secondly, penetration. The punch goes deeper into the material, starting to penetrate the die below, and the third phase is fracture. The material fracture under the force of the punch, creating a precise separation. This is different from the cutting action of a drill or hole saw, which generates swath and fillings. Clearance and calculation. Correct clearance between the cutting edge of the punch and the die is vital. It typically ranges from 4% to 8% of the thickness of the stock being cut. Too small clearance can cause trouble burnishing, while too large clearance results excessive burrs. Slug or blank ejection. The slug or blank ejected from the punching action require angular clearance. This allows it to drop through the die. The die has a straight wall at the top, angling off towards the bottom. Okay, next. Relation between die clearance with the cutting action in punch and die operation. Die clearance, typically expressed as a percentage per side, is the distance between a punch cutting edge and a die button's cutting edge. It's the amount of extra space that's needed to provide the leverage to shear and break the stock material to create a hole. In the context of CNC punching machines and CNC turret punching machines, punch and die clearance refers to the gap between the punch and the lower die when the punch is inserted into the die. This clearance is commonly known as the total clearance. It plays a crucial role in achieving clean cuts and maintaining the quality of punch parts. Way to improve punch and die operation. First, extend mold life. Next, effective material return, minimal burr formation, clear and precise hole, avoid sticking, workpiece leveling, accurate hole positioning, and minimum blanking force. Next, type of die in manufacturing process. There are four, which is blanking dies, piecing dies, bending dies, forming dies. Blanking dies is a metal production process during which a metal workpiece is removed from the primary metal strip or sheet when it is punched. The material that is removed is the new metal workpiece or blank. Piecing dies is a shearing process where a punch and die are used to create a hole in the sheet of or metal or plate. Bending dies, also known as edge bending, is performed by holding the sheet between a pad and die, then sliding the wiping flange across the face, pushing and bending the sheet metal which protrude from the pad and die. Forming die is a widespread sheet metal forming manufacturing process. The workpiece, usually a metal sheet, is permanently reshaped around a die through plastic deformation by forming and drawing processes. Drawing die. Drawing die used to shape cup-like article out of sheet metal and is punched into it by a punch and prevented from wrinkling by a blank holder which holds the outer edge of the metal foam. Progressive die is a metalworking method that can be encompassed punching, coining, bending, and several other ways of modifying metal raw material, combined with an automatic feeding system. Compound die produce a complete blank in one station at every stroke of the press. Combination dies perform more than one function but is not as complex. And progressive or compound dies, they are versatile and suitable for smaller production runs. Blanking die, piecing die, bending die, forming die, drawing die, progressive die, compound die, and combination die. Okay, complete the mold design. Die block. The die block serves as a foundation for the entire die assembly. It provides structural support and houses various components such as punches, stripers, and guide pins. Think of it as the sturdy base upon which the die functions. Punch and punch plate. Punch plate screen, also known as the punch plate, and perforated metal are sheet metal that can be stamped or punched to create pattern of holes, slot, or decorative shapes. Pilots, strippers, and pressure plate. The pilots are guided pins or bushing that maintain a correct alignment between upper and lower die section. The stripper holds the metal down during cutting or piercing, preventing it from sliding and distorting. The pressure pads tightly holds the metal against the lower die section before forming punch engages. Force mechanism involved in die mechanization. Die operation. Forming operation work by deforming materials like sheet metal or plastic using force, compression, tension, or both, and rely on the material mechanical properties. Forming die are typically made by tool and die makers and put into production after mounting into a press. Blank size. Refer to the initial flat piece of material before any forming or cutting occur. It's essential to calculate the blank size accurately to achieve the desired part dimension. Bending method. Air bending. The material contact the die only at 3 points, creating a bend angle. Bottom bending. The material contact the die along its entire length, resulting in a tighter bend. Coining. Intense pressure forms the material into a precise shape. Edge bending. bending along the edge of the material. Bending allowance and bending pressure. Bend allowance, the arc length of the neutral axis through the bend. It tells us how much extra length is generated by the bend deforming. This accounts for material spring back and ensure the final bend part matches the desired dimension. Bending pressure. A bending force is a force that is applied to a length of material. The bending force is applied to the point, area or volume that is some distance from fixed portion of the component or structure to achieve the desired angle without material distortion. Percentage reduction, depth of drawing force, percent reduction. In deep drawing is the reduction in the blank diameter as the material flow into the die cavity. Depth of draw, the distance of the material travel into the draw die cavity during deep drawing. Drawing force, the force exerted out on the sheet metal during drawing, affecting material flow and part quality. This is a blanking part. Blanking dies, assembly of the blanking die, a detailed drawing of the blanking die. Okay, an explored design of blanking die, top and bottom plate. The sustainable element to increase tool life and awareness of environment. A sustainable life elements to increase tool life. Use appropriate speed and fit. Using the right speed and fit setting will increase tool life significantly. Apply cutting fluid. The cutting process generates a lot of heat due to metal contact. The right type of cutting fluid and the right amount of fluid application will prolong tool life. Use the right tool. The complexity of the workpiece, surface roughness, require machining accuracy, tolerance requirements for the finished part, and other considerations are critical. For example, some workpiece may be strong enough to deal with high-speed steel tool. Awareness of environment. Way to protect environment. Reduce, reuse, recycle. Follow the 3 R's to conserve natural resource and landfill space. Shop wisely. Buy less plastic and bring a reusable shopping bag. Plant a tree. Trees provide food and oxygen. They help save energy, clean the air, and help combat climate change. Conserve water. The less water you use, the less runoff and wastewater that eventually end up in the ocean. Conclusion. In conclusion, in the intricate world of manufacturing, the tool and die play pivotal role, which the term tool encompasses a wide array of mechanical devices used in various processes. The die specifically focus on shaping metals. Die are the unsung hero behind precision metal stamping, ensuring that intricate design and functional components emerge from raw material. Also, it evolves using specialized tools and dies to cut and shape the metal into the desired form. Tool and die can be used for a variety of purposes, from creating small parts to fabricating large components. The process of tool and die began with a design. That's all. Thank you.